You can start it.
Today we're going to solve a hard linked list question where we want to reverse the nodes of the linked list k at a time. And if we don't have k groups at the end, then we're just going to ignore that part. And yeah, so pretty simple, but implementation is tricky. So we're going to jump right into it. As you can see here, k is 2, so there's only one node left, so we don't do that. 3 here, 2 left, we don't care about that, so cool. So first, let's create a dummy node, and then join it to the head of our linked list, and then create a pointer node that's going to start at dummy. This loop is going to run forever because we're guaranteed to have a solution, as long as, because the cutoff of k that's going to come inside of this while loop. So we're going to actually set a variable called traverse that's going to traverse exactly k nodes. And if we don't have k nodes left, then we're just going to return the linked list as we know it. Now we're going to actually reverse the linked list itself the same way you reverse the standard linked list, except we want to do exactly k. So pointer.next in k, because pointer.next was the back of the linked list or the front of the linked list now, and that's the distance we're going to reverse. So pointer.next is head here, and this is standard reverse linked list stuff, and we want to reverse it k times. So this is how we do it. Set it to previous, which is none, previous equals to current, move right 1, current equals to next. And then k minus equal to 1, so we don't get an infinite loop here. And then we just want to return previous and the current, because that's the new portion of the linked list we just reversed. For example, now you just have this empty linked list in midair called 2, 1. So now how to join this back into the original linked list, right? So we're going to take our current head and we're going to move it up 1, and we're going to take our previous dummy and move it to what head previously was. So we're going to call this right 1 equals to pointer.next, because pointer.next was originally at 3, so next again is 4. And then right 1.next becomes current, because right 1 is the actual head of the node. Of the new node we want to reverse, so that's going to be at 4. And then pointer.next equals the previous, because pointer was the dummy node, and we want to jump that to what previous now was, because this is the fragmented linked list, right? So previous is 2, current is 1, and we want to jump that forward. So 2 becomes 4, 1 becomes a position 3. And then pointer becomes equal to right 1, because right 1 is now going to be at exactly 3, because pointer.next is at 4. And then after we finish, we can just return the linked list itself. So this should work, but let's see. There you go. So
Okay. Can you tell me the time complexity?
Time complexity here is, I believe, O of n.
Mm-hmm.
But there's the space complexity is O of n as well, because we have to join them back together, and we have all these extra variables, but we're not using any extra data structures, but we do have this dummy node. So I'm going to say O of n. I'm not too sure, though.
Okay. Yeah, I think it's B of 1 maybe. Yeah, because it didn't. Did you create one more list node?
No, I didn't.
Maybe I think it's B of 1. Yeah. Yeah.
Okay.
You did very well in this question.